Let's see. Okay, it is being recorded. And well, I'm Chasco. I teach courses in applied econometrics in the Department of Applied Economics. And I also direct a research group that is devoted to the analysis of regional and spatial analysis. This research group is called EconRes, so it's a group devoted to regional and spatial economic analysis. And well, these classes are part of a whole course. As you know, this course is called Advanced Topics in Spatial Statistics, and this is a 10-hour seminar, which will be held during approximately this month, March, 1 month, during 6 sessions of 1 hour and a half of duration, except the last one, which will last 2 hours. I think that you more or less know about that. I'm going to project some slides, so let me share with you the desktop. Okay. Oh, sorry. So this part of the whole course is called Methodological Procedure for Evaluating Spatiotemporal Dynamics. So I'm going to talk about spatiotemporal dynamics, or panel data, if you wish. Oh, excuse me, it is translating. Oh. I don't mind. I don't want to. Can you see correctly the slides if I project this way?
Yes, we can. Yes.
I hope so. Well, let's see, just to avoid. Yeah. Okay. Perhaps it is better this way. Well, the table of contents for the course is here. So in this first session, I will revise some antecedents of spatial-temporal distributional analysis, which have been published in the scientific literature. Sorry, I'm going to turn off the camera because it consumes a lot of space in my computer, and yes, I think it is better. So in this first session, it's just an introduction. We will revise some antecedents that are present in the literature about this kind of spatio-temporal distributional analysis. In the second session, I will give an overview of a specific methodology to evaluate spatio-temporal dynamics in socioeconomic phenomena. It consists of 6 techniques which used jointly have revealed as very efficient. The first of these steps contains some exploratory spatiotemporal dynamics. So the acronym is ESDA. We want to explore the dynamics of this space-time dynamics of a panel data distribution. In the second and third steps of this methodology, I will revise the analysis of spatiotemporal distributional mobility with Markov chains. So perhaps many of you have heard about Markov chains. So this is what we are going to revise here. And we will add the role of spatial dependence. So you can add the role of spatial dependence in this distributional mobility inside the Markov chains. And this is what it is called spatial Markov chains. In the fourth step, the LISA methods are used to analyze the co-evolution of spatial neighboring regions. So we will analyze if spatial neighboring regions are evolving at the same pace or if they evolve differently. The first step tackled the problem of spatial regime disparities in the co-evolution of neighboring regions. We will use the GIMA statistic And the sixth and final step, analyze the spatial regime cohesion dynamics with the rank decomposition index. Well, hence, you will learn some specific tools. So this session, or the total sessions that I will give you are centered in the tools. There are some tools to analyze spatiotemporal distributional mobility of panel data, the ESTA, the Markov chains, spatial Markov chains, LISA method, GIMA, and rank the decomposition index. Here you have the schedule of the classes of this seminar. So this is more or less, so it's approximate. As you can see, there will be an assignment after each session that you will have to deliver using the Moodle activities. In total, you will have to prepare 5 assignments, more or less, which will be part of a final report. So in the end, you must present the final report, but this final report will will be done. So you will be doing this final report along the sessions. And well, this final report is the one that you will present during the last session. It will provide you with an exact structure of the assignments, of course, and the final report. So don't worry about that. I will tell you how to prepare these reports exactly. All the computations will be done with the R package called SDAR, built by Andrés Vallone, who is actually professor in the Catholic University of the North in Chile, but he studied in the Autonomous University of Madrid and developed this package during his PhD process when he was preparing the dissertation. And well, but we also will use Geoda. The Geoda software I will give you is very easy to install and very easy to use. And since it has some tools that are interesting and easy to use, this is why I will also tell you something about this package and how to use it in this context of spatiotemporal analysis. Each session length is 1 hour and a half, except the last one, which will be 2 hours, in order to have enough time for the presentations. The second session will be this Friday, on March the 5th. I will present the methodology and the first step of the ESTA analysis. In the third session, on Tuesday, March the 9th, I will develop the second and third steps of this methodology, consisting in the analysis of spatiotemporal distributional mobility with Markov chains, and the role of spatial dependence with spatial Markov chains, respectively. In the fourth session, on Friday, March the 12th, I will show you how to analyze the coevolution of spatial neighboring regions using the so-called LISA methods, which is the fourth step of this methodology. In the fifth session on Tuesday, March the 16th, you will learn how to compute spatial regime disparities in the co-evolution of neighboring regions with the GIMA, as well as the spatial regime cohesion dynamics with the rank decomposition index, which are the final fifth and sixth steps, respectively, of this methodology. In the last session, on Wednesday, March the 24th, each of you will present the results of an assignment. So it is an individual assignment, which will consist in applying the routines of this package or some menus in the Geoda software to compute the 6 steps of this methodology to a panel of spatiotemporal data. So you will have to work with real data, not only in a theoretical framework, but also in applied work. Well, the interaction professor-students will be held through 2 channels. I will use Microsoft Teams and Moodle. Well, first, please wait for me to open the session in Moodle. So I will open it like 15 minutes before, and try to enter to this session that has been opened by me. And well, I also would like to use Moodle to interact with you. So it is important to be inside Moodle and to enter the course. You will find your grades in the grader report of Moodle. So I will be evaluating you along this month in a continuous way, okay? And so it is mandatory that you enroll in Moodle. Please, now only 2 of you are actually there. So for the next session, you will have to upload an assignment and you must use Moodle to do that. So it is already prepared here, chapter 1. So you have a web page. You must enter, this is the address to enter the course. And you will have there all the, even these slides will be there. And you also will find the assignments, so correctly specified, okay? So it's important that you enter in Moodle. If you want now to to download the slides, they are also, because this is the first day, the first session, you will find them in the main page of the course here in Teams. You can find, I hope you can see them here in the chapter called Files. In this part of our channel, in Files, you will find session one slides. So this is the first one for the presentation. And now if you want to download it, you will find here the slides I'm going to use for this first chapter 1. And also, because as I said, it is the first day, so I will try to to adapt to some of you that are not in Moodle. I also uploaded this first assignment papers. So I will explain to you how to proceed, but you will see your name here and just before the paper. So this is a paper, and your name before means that this is the paper that is assigned to you. So each of one will have assigned one of these papers to revise them. After this session, so by the end, I will explain to you how to proceed, how to revise these papers. But you will find one paper for each of you. This is the idea. And you will have to do something, and this task must be uploaded through the assignment menu in Moodle. So you can find the papers here, but your work, your task must be uploaded using Moodle. This is why it is important for you to have Moodle installed, okay? Well, installed, you have it installed. To enter there, to enroll. This is the problem, that I cannot see you. Only 3 of you are there for the moment. So, okay, this is first a presentation of the sessions and the way I will proceed with them. And now, well, let's go to chapter 1, the antecedents. You have here also my email address. This is my institutional email address for the Autonomous University of Madrid. So my name, Coro, my second name, Chasco, at UAM, so Universidad Autónoma Madrid.es for Spain. And if you want to ask me directly something, you can write there. So, well, the first chapter is called Antecedents. Why? Because I'm going to, to present some very important papers in this literature of spatiotemporal mobility analysis. So this analysis, so when we talk about mobility, we are not talking about transportation or mobility of people like migration. We are talking about a distribution, and inside the distribution, there is a mobility. You can start, for instance, in the lower tail of the distribution and end up at the end of a period in the right-hand side of the distribution. So this is what we are referring to, if there is this kind of mobility. So this is a first idea that is important for you to bear in mind. Well, this is a complete list of very important antecedents. For instance, as you can see, so the antecedents, well, they are like 18 references, almost 20. These references are the main ones. Of course, there are some others, but for me, they are very, very important ones. They have applications of part of this method. So I will present a broader amount of tools, not only the ones that are specifically introduced in these papers. So these papers, particularly the first ones, are only using exploratory analysis and Markov chain, for instance. After Ray's contribution in 2001, we started introducing some other tools like the spatial Markov chains and other that take into account a spatial analysis specifically. Well, in this chapter, in these slides, you will find these 18 references that ranges from 1993 to 2020. So just the last one is of last year, but well, it is very important because I went to Google Scholar just to see how it is evolving. There are 8 papers already published in 2021. So in this specific year, we have now in Google Scholar 8 papers already published about spatial Markov chains, just this particular topic, spatial Markov chains. So if you introduce, this chain, spatial Markov chains, in Google Scholar, you will find about 8 papers that have been already published in this year. And there are like almost 40 from January of 2020 till now. So it is, a technique that is being used a lot in the recent years. So it is on fashion. It is really like a booming, topic. It is interesting for you that I can, teach about these topics in particular. Well, the applications of this methodology go from classical economic topics like GDP panel or per capita income to some other different topics like environment, regional population, even epidemiology. Now with the COVID, it has been applied a lot. So it is interesting because you can, these are tools, so you can apply them to whatever phenomenon that deals with spatiotemporal dynamics. You want to observe the dynamics in space-time of something. It is interesting to know this methodology. Well, the concrete methods. So don't worry now because this is a very introductory session. So now I'm going to talk about Markov chains, spatial Markov chains, certain exploratory spatiotemporal analysis, and sometimes some of you will know about them or perhaps not. But don't worry because we will go in depth in the future sessions. So this one is just to introduce something and to start explaining about what they are dealing or the contents of these methods. So okay, let's go to this first paper. So this first paper, for me, it's very, very important. It was written by Danny Qua in 1993. It is entitled Empirical Cross-Section Dynamics in Economic Growth. It was published in the European Economic Review. Well, the aims of this work are twofold. First, it examined the determinants of long-run economic growth. So this author was interested in analyzing the determinants of long-run economic growth. And second, it aimed at checking to what extent per capita income converged towards a steady-state growth path, possibly differing across economies. So, in general, analyzing the determinants of long run and specifically checking for convergence or non-convergence among, in this case, among countries in the world in terms of per capita income. To these purposes, he applied different methods. So first, this one that we can see here, spatiotemporal data analysis, exploratory spatiotemporal data analysis, or ESDA, on the main variable. The main variable is per capita income growth in this case. And second, he also applied the method of the Markov chains to study the intradistributional mobility of this variable, but mobility in the sense that I said before. So it's not transportation and something like that. It's mobility inside the distribution of per capita income from a starting period to an end period. In this slide, I present the ESDA, ESTDA analysis, which consisted in two scatter plots for a panel database of per capita income. We have 181 countries during the period of 1962 to 1985. So it's more or less a long period, more than 20 years. In the first scatter plot, we represent the scatter plot of income growth of the world countries. So from 1974 to 1985 in the y-axis. So it's income growth of the world countries on also income growth in a previous period from 1962 to 1973. And it will be represented in the x-axis, is at the left-hand side, the first scatter plot. In the second chart, we represent the standard deviation fluctuations across the country cross-sections in these two periods. So we have these dots are the values of per capita income. In the x-axis, we have income growth, so they are growth rates. Income growth in the x in a previous period, so from 1962 to 1973, and in the y-axis, we will have income growth, but from 1974 to 1985. Okay, he found that the data showed instability. So, well, you can depict, a straight line, but the dots are up and down. So a lot of instability in the long run growth patterns during this period. In fact, it was computed that 78 of them experienced a reduction in income growth. So it is quite, I don't know if you can see all these dots that are just on here, the letters in red. So very low or here, low, so low growth rates followed by low growth rates. So it is something that is worrying. Regarding variability, so at the right-hand side of the slide, variability in per capita income growth rates, each country's income showed rising dispersion rather than falling over time. Additionally, these shocks to each economy appear more important at the end of the sample than at the beginning, which are very interesting. So you can see that at the end of the sample, you have more variability, more differences. Well, you will have a heteroscedasticity, more or less, and this is not weird, but also interesting. No, 75 of the 118 economies experienced an increase in income variability. So it is important to analyze why. No? And this is, the importance of this exploratory analysis. So many people go straight to the models. So models are very important, but you must first look at the data, because if you don't understand the data, you can say very stupid things with the models. So, and I'm a modeler, I love models, but I must say that if you don't know how data behaves, it's very important. So you can make a lot of mistakes. This is my main message here. So after the ESDA properly employed the method of the Markov chains to study this intradistributional mobility in the panel data of 181 countries during the period of 23 years, from 1962 to 1985. He defines this variable as each country's per capita income relative to the world average. Sometimes in many of these kind of analyses, the variable is relative to a general average. In this case, since we have countries, so the per capita income of each country is compared with the world average. This is what we are saying here. So it's always we are analyzing this mobility, but in relative terms. In order to build the Markov chains matrix, this variable, so per capita income, was discretized into 5 intervals in order to divide the observed data into roughly equal-sized categories, from 0 to 1/4, from 1/4 to 1/2, from 1/2 to 1, from 1 to 2, and from 2 to the infinity, being 1 the situation of a country with the same per capita income that the world average. This is the idea. So a continuous variable, like per capita income, is made discrete in order to do or to apply this methodology. Each element of this matrix is a probability. So these numbers that you see here, 0.97, 0.03, etc., they are probabilities. Is the probability that an economy in a determined interval or a state J in one period transits to a different interval or a state K in the following period. Hence, low-numbered states correspond to low incomes. So, for example, 1/4, so it even 1/2. No, they are low incomes, but relative to the world country distribution. For example, state 1 comprises per capita income no greater than 1/4 of the world average. So very lower income countries. Okay. Sorry, here. This matrix contains the one-step annual transition matrix. So each of the, of the numbers represents a probability of departing in one state in the first period and going to another state, or even the same one, in a final period. But it is a one-step understanding by a step the states. So one-step annual transition matrix. It has been estimated, so this Markov chain, because you can build the Markov chain in different ways, as we will see, but this one was a one-step annual transition matrix. It has been estimating by averaging the observed one-year transitions over every year, starting from 1962 to 1963 through 1984 to 1985. The first column gives the total number of transitions with starting points in the lower income state. That is, being lower than 1/4 of the world average. This is the first columns. This is what it gives. The total number of transitions starting in this lower income state. On its side, the second row shows that over the entire sample across 118 countries and 23 years, 643 observations end up falling in state 2. That is, incomes between 1/4 and 1/2 of the world average. This is, what is highlighted here. So this 643, so is the numbers of observations ended up falling in state 2, let's see. I don't know if it is. No, it's, sorry. Only say the second row shows the over the entire sample across. No, I think it is not correct. So in this case, these 643 are the number. Oh, yes, of regions that ends up in this state 2. Let's go to the of these 643 observations or intra-distributional transitions, 92 remained in the same second state in the following year, and it is called persistence. So you can see this 0.92. Why in the diagonal matrix, in the main diagonal, you find these very high values, very high probabilities? Because the probability of starting in one state and ending up in this state is very high. So what it is really, significant or very, I don't know if to say weird, but very rare, is to jump from one state to a different state, because these states are relative. So perhaps income per capita is going high, but if it is growing also in the rest of the world. So perhaps you are growing, but the others are also growing, but jumping and growing more, significantly more, and jumping up, or growing at the very lowest pace and going down. This is what it is not frequent. This is the idea of this main diagonal. And when this main diagonal, the numbers are very high, we say that there is a high level of persistence. This is the word. Looking at the rest of the values in the main diagonal, we find a high persistence, as I said. So in this case, they are the world countries, and it is per capita income. So from year to year, we cannot find in this period of 23 years in the past, we couldn't find, a high mobility. On the contrary, we find persistency. In this second panel, QA represented the long-run trend of per capita income across the world countries. So it is a long-run trend. Why? So this is like the first, like the previous one, but it now describes only one transition of 23 years, from 1962 through 1985. We also see persistence, that is high values in the main diagonal, but less pronounced than in the short run matrix. So it is interesting. So it's a different scope of looking. This is why these numbers are lower, because they jump and only jump from 62 to 85. This is the the scope here. For example, 7%, this 0.07, 7% of the economies at the state 2 in the origin year of 1962 jumped or transited to incomes at the world average or even higher, to states 4 and 5 over this longer horizon in 1985. However, this long-run mobility is not all favorable. Why is not so good? so favorable. Of those same 7% of the economies originally in state 2, over one half dropped to even lower incomes. This is what we see here with this 0.5. So it's really important to analyze these results. What this kind of analysis means is that we have a great variability or heterogeneity in the results. So it's a, very fine analysis. In fact, looking down the neighborhood of the main diagonal, so looking down this main, so this, square that you can see here in red, okay, it suggests that at low incomes, the greater tendency is to become even poorer, although some possibility of upward mobility always remains. Hence, Qua concluded that countries caught in a low-income development trap tended to remain there. So it is very hard. Countries caught in a low-income development trap, they tended to remain there, to remain in this trap. So it is curious, like how Qua reached these conclusions and the methods that he employed. Here we have another Qua's paper. It was published in 1997 in the Journal of Economic Growth. It was entitled Empirics for Growth and Distribution, Stratification, Polarization, and Convergence Club. Sorry, I'm going to drink some water. Well, this paper also studies the cross-country patterns of economic growth. It is like a continuation of the other paper. In this case, he found a profound empirical regularity of emerging twin peaks. So the main idea here are these twin peaks that are depicted here. So it's like a theoretical representation of distributions. So we have these twin peaks in the cross-sectional distribution of per capita income. That is, we don't find, so in this T plus S period, I don't know if you can see, it's a future period. So we have the past and the future. So in this future period, we don't find simple patterns of economic convergence or income divergence. They are not simple patterns. We have this complex distribution with these two peaks. Hence, from a theoretical point of view, he found with this paper, with this analysis, the existence of interaction patterns among subgroups of country economies. So it is not a problem of single special economies that are accumulating factory inputs and technology for growth. So single, very outstanding economies, but subgroups of interconnected economies that are evolving together in this, making these clubs. This is what it is called convergence clubs. So from a one world to two different worlds, the poorer and the richer, we can see. So it is very appealing, this chart that we find here. In this case, for this paper, he only applied different methods for exploratory spatiotemporal data analysis, or ESDA. He applied these methods to a new panel data, very similar to the other one, of 105 countries over 1961 to 1988 period. First, he represented the kernel cross-sectional distributions for certain years. Second, he used a three-dimensional chart to represent each of the cross-section and time series distributions. Third, he also represented the cross-section distributions at certain periods with box plots. And fourth, he used a kind of graphical representation for the Markov chain transitions. So let's see, and let's go in this, what we see in this slide is this first part of the ESDA analysis that present shapes of distributional dynamics with the kernel distribution. So it is interesting to analyze the kernel distributions in these different moments of time and see if these shapes vary or not. So this is the case here, a great variation. And well, this figure, as I said, provocatively shows the distribution at a future period of t plus s with this twin peaks property, with two clusters of the very rich countries and the very poor, and a kind of vanishing of the middle income class. So no middle income class at all. So this is the main conclusion that he reached with this paper. In this new figure, in figure 2 of the paper, he represents a three-dimensional figure or three-dimensional chart. He plots here the log of per capita incomes across each of the 105 countries, all relative to the world average in each year, and it does that for each of the years from 1961 to 1988. Maybe it's different to observe. You must observe this chart from different points of view, and it is not very easy to understand, but it's another way, of course, of representing space-time distributions, as you know, because it has been used in many other papers. And the third figure he used looks across 3 decades. So, well, they are the 60s, the 70s, and the 80s, but they are 4 moments in time. So 1961, that is the first moment, 1970, the first moment in the 70s, 1980, and 1988, okay? Well, in 1961, we can see a clear twin peak form. So we have the main mode and a small mode at the right-hand side of the distribution. By 1988, the second peak continued. You have here the second peak, continued being pronounced. But what we see is that the first one, the average, is less pronounced. So how to interpret this evolution just at looking at the kernels? It could be concluded that the rise of the richer peak occurred at the expense of the poorer one. So perhaps you don't see a great rise, but since this is more, flattened, what we see is that this mode continued and even was higher than this other one, but at the expense, because it is flattened, of this middle class income, because it is per capita income. So it is the middle class, the main mode. So also a very worrying result. If we use now, these same distributions, the same one for 1961, etc., but we now apply box plots. What we see here is that they don't show lower outliers. So this is great. So we don't have lower outliers while we have upper ones. So the upper ones are these dots corresponds to countries. So with very high, compared to the rest of the distribution, very high values of per capita incomes. But we don't see this part, so these countries in the lower part of the distributions. But what does it mean? Well, first, that we cannot find extraordinarily poorly performing economies. So we cannot find very, very poor countries as isolated cases that, must be specifically highlighted. But Qua derived that when economies performed especially badly, they were not alone. as isolated cases. They are clustered. So this is not good news. What it means is that these very low-income countries, well, there is not one or two that are horribly poor, but they are very poor and they are clustered, and this is why you don't find outliers. This is the idea. However, on the upside, it did show several outstanding performers or upper outliers of countries. However, these initially outstanding economies, these ones in 1961, these dots here, were progressively being caught up by the rest of the world. As you see, you can see less outliers, and in the end, only two ones here. This is the idea. So the rest of the countries has progressively caught up these outstanding ones in the beginning of the 80s. And because the number of the upper outliers are lower than in the end than in the beginning. Additionally, the lower part of the box plot has never risen. So as you can see here, this low part is in the same position. So many countries in the world are growing, but the lower ones, the ones located in the lower parts, stay as poor as in the beginning, And so relative to the mean, even relative to the mean, they show a continuing decline because the mean value is here, is this straight line that is depicted here. So, and what we can see is that these very lower income economies are farther from the average. This is the idea. That is to say, other parts of the world remained poor during this long time period, and the same as poor. So also a very worrying result. This other chart is very interesting because it represents the intra-distributional mobility of country income per capita relative to the world average over this period, from 1961 again to 1988. So it is a representation of the Markov chain. What Qua did is discretizing the space of relative income values and simply counted the observed transitions out of and into distinct discrete cells. So again, like in the Markov chains, what he has done is here in the vertical axis is dividing the continuous distribution of income in different states or different intervals. And you have here the first period of time and the last one. So T and T plus S. It could be 1961 and here the 1988. It is an easy way to quantify churning or intra-distributional dynamics. It's a way of looking at these dynamics. For instance, if we depart from this kernel, so he also represents the kernels, and we can see that in a sequence of distributions. So if we go to the cell 2, this is the cell 2 of lower income interval, we can add up the number of transitions out of this cell 2 into cells 1 and 3. So these arrows represent, the countries that departing in lower income positions went to higher income ones or even lower ones. They could even worsen this situation in the last period. Okay. Using these discrete cells, we can construct a transition probability. So it's a way of, representing a Markov chain matrix. Here in the last figure, Qua represented two types of kernel distributions. These shapes are interesting to analyze. So if relative per capita income distribution in the first period was like the left-hand side one of this slide, then it implies convergence of the entire cross-section to a single point mass. So they, the distributions, the two ones, so they converge towards a single point. So we have one world going to a steady state, to a same point of average income. But the representation in the right-hand side of the slide, what it means, is clustering. So clustering, polarization, stratification of the world countries into, in this case, two convergence clubs. As I said, so the poorer, here in the down part, and the richer in the upper part of the chart. So it is important when you represent the kernels of the cross-sectional distributions in different periods of time, that you understand the shapes, because the analysis of the shapes will give you a very important message. And it is not like a model, but it prepares a model. And it is very important, to see what is happening, even to find the best model. And not to avoid or to forget an important or relevant variable. So this is the message I want to give you with these first antecedents: the importance of looking at the distributions, of preparing good charts that are smart, as we say now. And that gives you this important flavor or message about what is going on inside this distribution in a period of time. Well, here we find a third very, very important paper. This third paper was published by Serge Rey. Serge Rey published this paper that was entitled Spatial Empirics for Economic Growth and Convergence. It was published in 2001 in the journal Geographical Analysis. This paper suggests some new empirical strategies. So it introduced new strategies for analyzing the evolution of regional income distributions over time and space. So this is achieved by integrating some local spatial statistics, so these LISA statistics, within a Markov framework. A number of indices are suggested as ways to characterize the space-time dynamics and are illustrated in a case study for the US regional per capita income dynamics. So regions, the US regions are the states, over a period from 1929 to 1994. So it's a very long round period. Hence, we will find here two important novelties with respect to the previous QUAS papers. Rey first sets the analysis at the regional level, inside one country, not at the country levels in the world. And second, he includes a new set of indices to compute spatial autocorrelation effects that weren't computed before in QUAS papers. In this table that you have here, what Serge Rey did was contemplating two stages for the study variable. So they are these two columns. Being above the country average, you now must think on regions or states in the United States, so that the states or the regions are above the country average, versus being below the country average. So the abbreviations here are HH, LL, HL, LH, and these are the ones that correspond, if you remember, because the students must have studied spatial analysis and spatial econometrics, so they correspond to the typical abbreviations used in the Moran's scatter plot. So HH corresponds to regions with high values of a variable that are above the average, which are surrounded by regions with, in average, high values of this variable. So high values of a variable surrounded by, in average, high values of this variable. Low corresponds to regions with low values that are surrounded by regions with low values in average. And HL and LH correspond to regions with high values surrounded by regions with low values, and vice versa. So low values surrounded by high values. So they are this kind of negative spatial autocorrelation. High surrounded by low, low surrounded by high. And okay, so Ray also employed the Moran-Sai scatter plot. It is interesting to see how he does it. And additionally, well, he, of course, in this same paper, will use the Markov chains and the spatial Markov chains analysis, okay? In this case, as you can see, he depicted the situation of the states, of the regions in the United States, in a Moran scatter plot. In this Moran scatter plot, as you can see, the values of the variable per capita income are standardized. So here, this point in the middle, so in the crossing lines, means that the country average is, approximation for the country average. So from the country average to the right-hand side, we will have higher values. To the left-hand side, lower values. And in the vertical axis, we will find the spatially lagged values for each state. Okay? Particularly, what he's doing is, you can see here, is representing the growth rates. So they are the growth rates in a first period from 1932 to 1976. But this is for the main variable, so per capita income. And he also represents the spatially lagged value of these values of income growth rates, but for a future period, or I don't know, no, it's the same one, 1932 to 1976, okay? And we can, make this analysis. So this first quadrant is the quadrant of high. So regions with high growth rates, okay? Growth rates. It is not now income levels, but growth rates. With high growth rates in this period of 1932 to 1976 that are surrounded, because in the vertical axis are, for each of the states, the spatial lag. So, the average of the per capita incomes of its neighboring regions, so that are surrounded by regions that in average are also high in per capita income. So it is the high or HH quadrant. This is the low quadrant, just the contrary, lower values of per capita income growth that are surrounded by lower values, surrounded by lower values in average of the neighboring states in per capita income growth. So they are high income growths that are surrounded by income growths, and low income growths surrounded by low income growths. And as it is, when we have positive spatial autocorrelation, it is normal that these others, so it is a low-high and high-low quadrants, have few observations. Okay, what he did is, in order to compute these neighbors, so the question for people that do not know how these kind of statistics are derived or representations, it is normal that they ask themselves, but the neighbors, who are my neighbors? who is every state's neighbor, no? And what Serge Ray proposed is using what it is called a first order spatial contiguity matrix. That is, each state's neighbor are the ones that have a common border. So the neighbors, the states have borders, so if you share with me a common border, you are my neighbor. This is the idea of computing neighbors. So in this scatter plot, what Serge Ray found is that he could identify some clusters or regimes, but they are of local spatial autocorrelation. I more or less depicted them with these two round circles, so a high growth rate cluster in quadrant 1, these states. So they are specifically the southern states. So the southern states were states that during this period of time grew higher than the average in the United States, and were also surrounded by states that in average also grew higher. This is the idea. And the same for the low quadrant. We can find a low growth rate group of regions in quadrant 3. So this is the quadrant 1, the 2, the 3, and the 4. Okay, so in quadrant 3, and which are they? They are the northeastern states. So the northeastern states of the country were the ones that grew at a lower pace than the average of the country, and were surrounded by neighbors that also grew at lower pace or lower speed in average. So it is interesting how using the Moran's scatter plot to analyze this intradistributional phenomenon. So don't forget that we are representing growth rates. This is the point. No, not levels as it is usual, but the growth rates. So the Moran scatter plot provides important insights to the spatial dimension of a regional income distribution in one point in time. Well, in this case, what Ray represented were the growth rates, as I said. So the jumps, the growth from one point in the past, 1932, to one point in the future, 1976. Next, the Moran's scatter plot represents 4 mutually exclusive classes. If you can see here, we have these 4 quadrants: quadrant 1, quadrant 2, 3, and 4. These quadrants are like classes very, very specific, because they are taking into account not only the distribution of the per capita income, but jointly with the distribution of neighboring per capita income, neighboring states in this case. And this is very interesting because we have these 4 mutually exclusive classes that in the end, what we have here are 12 possible transitions of per capita income growth. So in time, this is what is represented here. So, for instance, a state that was in period T in the quadrant high could go in a future period to another quadrant, low-high, low-low, etc. So in turn, these 12 transitions can be broken down into 3 groups, 1, 2, 3, that are the ones that are represented here. For example, a state or a region that goes from high in T to low-high in T plus 1, a region moves from high to low, but its corresponding neighbors remains in H, in high. This is the type 1. So a type 1, what is the type 1? So the type 1 is the one that you have a relative move of only the region, but not the neighbors. You know, so if a region moves in these terms of, you know, the intra-distributional setup, if you have that a region move, but not the neighbors, this is a kind of movement that is called type 1 by Sedgwick. Type 2. Type 2 involves a transition of only the neighbors in relative space, remaining the region in question in the previous state, so in the same state than in the previous time. So the only ones that move are the neighbors jointly of each state. For instance, a state that departed in low and ended up in low, but the neighbors went from low to high, for instance. This is the idea. And type 3 contains periods that witness a transition of both a region and its neighbors. So everybody changes. The region goes up or down, and the neighbors can go up or down. This is the situation for these type 3 movements. There is also a type 0. Type 0 could determine, since in addition to these 12 transitions, there are 4 cases in which the region-neighbor pair remains at the same state. Serge also represented all this in on a map. It is interesting because for us, maps are very, very important. And what we see here is the map for the intra-distributional mobility. So it's a kind of Markov chain representation also, but very simple one. So we identify a stationary situation, upwardly mobile and downwardly mobile. So what Ray is doing here is representing the number of regions that are experiencing any kind of mobility in time among some discrete states of per capita income. So, for instance, regions that experienced an upward mobility from a low to high income level state, from low to high income level state, and stationary. Stationarity is in mobility. So regions that from the first to the last period, they do not move. So they remains in the same position, in the same state. So what we can see here is a visual evidence that these transitions are highly clustered in space. So please, now what we represent with the colors are the movements of the state, only the states, not the neighbors. No, forget about the Moran's eye scatter plot. Here are the states, so states that go upwardly from the first period, 1929 to 1994. The ones that went downwardly started higher in 1929 and ended up lower in 1994, and states that remained in the same position. And what we see is that the representation of these colors are clustered, you know. This is what he found, these transitions. So the way that states move are clustered in space, More specifically, Ray found that 20 states that ended the study period in a higher income class than they started in, so upwardly mobile, are clustered in the southeast and central portions of the country. That were the ones that grew faster. At the same time, the 15 states that shifted down one or more income classes are found in a western cluster and dispersed throughout the industrial heartland, you know, this inland industrial one that suffered a lot in the United States. So are the ones that experience downwardly mobile. So they are more scattered, not so clustered than the other ones. And well, finally, there is a block in the northeastern states that end the period in the same income class, normally the highest ones, that are the ones in white, totaling ones. So in the same income class that they started in. Okay, and finally, Serge Ray also represent the spatial dependence analysis of the Markov chains using a specific, some expanded Markov chain, Markov matrix. It is called a spatial Markov chain matrix. So it is a modification of the Markov chain. It consists of conditioning regions transition probabilities. So the probability that the region experiences the mobility up, down, etc. It is conditioned on an initial income class of its spatial lag. Okay, so we now take into account the spatial lag. So this matrix decomposes the K by K transition matrix, the normal Markov chain matrix, into K by K by K system. In this table, the number of classes or states K are equal to 3. Low, medium, high. Low, medium, high. So we can see this low, medium, high here, and low, medium, high repeated for each low, medium, high corresponding to the spatial lags for each region, for each state. For example, let's go to this element. So this element, I don't know if you can see, it's this small m sub, let's see, sub HL, this bar or line L. So it is in the third row of the first column. So this is the first column and third row. It corresponds to the part of the spatial lag, the low income part. So what does it mean? Well, it means that the number of regions, or the probability that, no? So let's see, the regions that starting in 1932 with low per capita income, okay, with high per capita income. So they start with high per capita income, end up in the last period in the low per capita income state, conditioned because they were surrounded by neighbors that in the beginning they had a low per capita income. So these three rows correspond to regions, as we see. These first three rows, low, medium, high, are the regions which had low income neighbors. So we represent, they are like three Markov chains. Three Markov chains considering the neighboring for each state or for each region, the neighbor's income level. So here, the regions that had lower income level neighbors. So the ones that departed in low and ended up in low, the probability of starting in low, because they are going to be probabilities, and ended up in medium, etc., etc. So it is very interesting looking at the results, because these three Markov chains are conditioned to the levels, the income levels of the neighbors. So it's a way of looking at the neighbors and see if my neighbors are influencing me or are influencing a specific state. And if this influence, you can see them on a map, and they are clustered also. So they happens at the south part of the country, the north, the center, or wherever. And well, we are going to stop here this first session of classes. Okay, I know that there are more slides. I continue them the next day. And well, as I said before, you have to prepare a first assignment, okay? So this assignment consists of preparing a presentation. I think that you can see, yes, sorry?
Professor, I checked the assignment. I did not find my own there, my paper.
Please write me an email. Do you remember? I have the email address in the slides here in the beginning. So write me an email and I will give you right now a paper for you, okay?
Okay.
Because what you must do is, let's go to Moodle here. Here in Moodle, okay? You must, well, this is the paper folder. You have the papers here, the same as the ones that are here, these same papers, okay? But you must upload using Moodle because it is easier to correct and to give you a feedback and etc. So this is why I asked you to come here to Moodle. And this is, you know, the assignment menu to upload this paper review. So in this paper review must be more or less as, you know, the presentations that I have made here for each paper. So what I want you to do is preparing a presentation of your paper. It must be, you know, a 3 or 4 slide presentation in a PowerPoint, or it is better if you print this PowerPoint file with a PDF in a PDF format, because it is easier to upload, but it doesn't matter if you also upload the PPT. And what I want you to do is more or less what I did. So presenting the complete reference of your paper. The papers I assigned you are papers all referred, if you can see, all referred to 2020, 2021. So very, very modern and very new ones. And you will see very different representations with colors, and also, you know, more sophisticated presentations for the exploratory analysis. The Markov chains are more or less, and the spatial Markov chains are more or less the same, okay? And because I am presenting you the antecedents, the historical ones, but you are now going to read more modern studies, not only about income, per capita income, but some other topics that are going to broaden broaden your mind. This is what I expect. So you must prepare like 3 or 4 slides in PPT or finally PDF, presenting the complete reference of the paper, the objectives of the research, so why the research has been done, the methods employed. This is very important. So present some of the, you know, the figures, not all the figures, but the more representative for you, and explain briefly what they are about. And please also extract some conclusions derived from these methods. The ones that the authors, of course, so you don't have to do anything by your own, only copying what the authors have said, have written in the papers, okay? The deadline for this assignment is next Friday. I will give you next Friday at 1 p.m., just at the beginning of the next session, okay? This is the time you will have to present and upload your brief presentations. And I also would like you to fill a quiz that I have prepared here. I don't know if, yes, let's see. Yes, here you can now fill this quiz. It is a very simple one, and I would like you know to know how you feel with my class. If you have some concepts that have been clarified or known for the first time, or if you have doubts. Of course, maybe you have many doubts because I have gone very briefly over all the well, some of the methods, and as I told you, I will explain them in depth during the rest of the sessions. Okay, and that's it. Please fill in now, because it has a deadline for in 15 minutes. And I would appreciate if you fill in this quiz, and that's it. The class is or the session is over. Thank you very much for your attendance, and I see you on Friday. Okay, and if you have any doubt, please, it is better, since I don't have much time during the classes, that you write me an email and I will answer your questions. Perhaps we can open in Moodle, you know, a forum or something similar. Yes, a forum for discussion. If you enter in Moodle, maybe you can open, you know, a thread and a discussion topic, and we can talk about the doubts you have, and I can explain them to you. This is why I prefer Moodle. But if these first times you have some difficulties, you can send me an email. It is quicker. Okay. So goodbye. See you on Friday. Okay. Goodbye.
Bye.
Bye-bye.